So good morning, guys. Today we are going to learn a lot of things, about merge sort, about a linked list, about a double linked list, and finally we are going to solve a medium problem on merge sort and doubly linked list. So the main goal is to not just solve this problem using merge sort and doubly linked list, but the main goal to solve this particular problem is to understand how merge sort actually works, how a double linked list actually works, and how to make a faster solution better than these double linked list. So if you very clearly observe, like what the question of GFG tells us is, we will be given a pointer or reference to the head of a doubly linked list, which has n nodes, and the task is to sort the given linked list using a merge sort in both non-decreasing and non-increasing orders. So if you see, for example, you have certain number of values, and when you put these values as output, the output comes in two orders. The first is non-decreasing. Non-decreasing also says increasing. So if you are saying something as non-decreasing, it means that it is in increasing order. So if, for example, 1, 2, 3, 4, 5, 6, 7, 8 is the sorted version of this given values in a increasing manner, which can be also said as non-decreasing, and non-increasing can also be said as decreasing manner. So you have to just be careful with the English over here, and apart from that, things are very simple. But the task is to find the time complexity of O n log n and space complexity of O n log n. So here comes an interesting fact. Like, I have tried to solve this problem into two aspects. First is the one which is given in the question, that we have to solve the problem in using merge sort. So if you solve the problem using merge sort, the time complexity is obviously O n log n. But I want to try this using a sort, like the inbuilt sort method, and just completing this code within few lines of code and not at all using a merge sort. And I have checked, both of them are giving like accurate results, and all the test cases are being also successfully passed in the second, like even without using a merge sort. So definitely what we can try is, first we are going to understand the topic in depth, and then we will code this particular problem. So let's come to the question. So first the question is doubly linked list in a data structure. So what you know by data structure? Data structure is a structure which defines a set of algorithms, and those algorithms are being used particularly in order to solve a particular problem. So if you see carefully, this is a double linked list in which there is certain advantages. So like, you already know what is a linked list, right? So a linked list has no size, a linked list has a faster efficiency than an array, and all those things. But in case of a doubly linked list, we can have a reference in bidirectional arrays. So that means a doubly linked list can be traversed in both forward and backward directions. So if you see here, if you are standing in this particular position of A, you can go back and you can come back. The delete operation in doubly linked list is more efficient if a pointer to the node to be deleted is given, okay? And we can quickly insert a new node before a given node. So in a single linked list, to delete a node, pointer to the previous node is needed. In this previous node, sometimes the list is traversed. In doubly linked list, we can previous node using the previous pointer. So basically what it is telling, that you know the addresses of the front and the back. Say for example, a very good example I always give whenever I talk about linked list is a train problem. So whenever you are seeing a train and you're sitting inside one of the coaches of the train, you can see you can go in front and you can go in back, right? So similarly, imagine a doubly linked list as like that. You can go in front, you can traverse in the backward direction, right? So next come to the problem. It is saying merge sort using doubly linked list. So say for example, we will given a linked list, say with unordered list. So if you see why it is unordered list, because 88, 43, 93, 27, 12, this is an unordered list. We have to give the list in 12, 24, 27, 43, 88, 93. So if you see this is an increasing. This is an increasing list. Or whenever something is increasing, we can say it as what? Non-decreasing. So increasing can be written as non-decreasing, right? So let's come and analyze a problem. Say for example, we are given a array or the list of elements with unordered elements. You can see 8, 3, 4, 6, 1, 5, 7, 2. So you can pretty much understand and figure it out. This is not in order. So this is not in order, right? So the next task will be to divide and conquer. So like I have already discussed about divide and conquer policies. Like what divide and conquer actually does is, we have to break the particular linked list from the middle, and we have to create two sub-linked lists. And then we have to perform the sorting operations and substitution operations. So if for example 8346 1572, when we are dividing it, it becomes 8346 and the other half becomes 1572. When further, so whenever you are performing divide and conquer, recursion in a merge sort, so in merge sort, this is a very important concept that first you have to do divide and conquer. We have to divide it in such a manner that it becomes the single most atomic element. So in order to make it the single most or the smallest element, we have to divide it into subdivided problems and problems. Say for example, 8, 3, 4, 6 is subdivided into 8 and 3 and 4 and 6, and 8 and 3 can also be subdivided into 8 and 3. And individual 8 and 3, when we get individual elements of a sub element, we have to then what? We have to sort it according to the order of the element. Say for example, 3 is lesser than 8, so 3 will come first and then 8. Similarly, for the rest of the sub arrays, if you see 4 and 6, 4 is already sorted, so no changes over here. And if I see 1, 5, 7, 2, 1 and 5 is also no change. But in the case of 7 and 2, 2 is lesser than 7, so 2 comes first. Now, once the first line of sorting is done, whenever you see first line of sorting is done, again you can see another array is created using merging this array. So if you merge this particular array, what you will get is a combination of 3, 4, 6, 8 and 1, 2, 5, 7. Similarly, we have to perform recursion over here and then again merge it to give the resultant array, which is sorted order, which is in increasing order, and which is in non-decreasing order, right? So this is the condition. So you can see in the image, we can see the functioning of the merge sort. Merge sort, we divide the list into two smaller lists at each step and call the same function recursively on both the smaller parts. So I'm telling you one thing very clearly. If you don't know the concept of recursion or how recursion works, this problem is not for you. You have to understand what recursion is and you have to understand how recursion works in the back of a program. So I have found an alternative approach which I will discuss today in the end of the program, and the approach is slightly easier and faster than this merge sort of recursive approach. So let's complete it. From recursion, we can get two sorted lists, which are then merged by a function, say merge, and the final output is a sorted list, because you can see the final output 1, 2, 3, 4, 5, 6, 7, 8 is a sorted list. But how we are going to apply this to doubly linked list? The answer is simple. We will first find the middle node of the linked list. So you are understanding this particular diagrammatic representation by what? Because this diagrammatic representation is denoting an array, right? It's giving you the idea of an array. Oh, this is an array, and this is how typically a merge sort works. We break the array, we divide it, and then we again merge it, and then we recursively call the function, and then again merge it, right? But in case of a linked list is working on the condition of pointers and head and a node. So it's denoting the front direction or back direction. The previous pointer is denoting the previous direction, and then between them there is a linked list, right? So first we have to find the middle of the linked list, similarly the way we have done in case of arrays. Then we have to split the linked list around the middle node and make two recursive calls on both these sub-linked lists, right? So the algorithm is basically the same. So you can see first this is the algorithm: find the middle node, split the list around the middle node, recursively call the merge sort on both the sublists and merge both the sublists. But in how to find the middle node, we will maintain a fast pointer and a slow pointer. Initially, both the pointers will point to the head of the linked list. So say for example, you're standing in the train and the front we have the AC coaches, in the back you have the sleeper coaches. So if I take the AC coaches as the front coaches, so we can clearly understand that we have to point towards the head, because our front and our engine of the train is in the front, right? So we will focus on the head. So initially, say for example, current dot head, current is the current, we can think as the current is the particular linked list pointer. So if you see the pointer, you have to put the pointer as head, just because you have to initialize it as the head direction. Now we will move the slow pointer one node and the fast pointer by two nodes at a time. When the fast pointer reaches the end of the node, the slow pointer will move to the node. So we'll return slowly. Merging the two linked lists, how we can merge? By creating a merge function to merge the linked list. This like a merge function, you can see list 1, the node of the first element, first list, and list 2, there will be two nodes. Okay. So now let's understand this problem very clearly and try to solve it. Okay. So you can see, but before solving it, you can see there will be a class node. So class node is the constructor of the node class. So if you see class node is there and you have created a node constructor. In this node constructor, this is a parameterized constructor. In the parameter, we are passing data, and there is a global variable data, right? So this data can be inherited and this data can be used in anywhere in this class solution. And if you see, the node has two pointers, the next pointer and the previous pointer. Next pointer showcases the direction you have to move front, and the previous pointer showcases the direction you have to move previous, right? So in node IT data, in data, what you can clearly see is first we are like referencing that this particular data is equals to data and next equals to previous equals to null, right? So, but if you see, this is a very short code, but main thing is the class solution, which has a static node sort doubly. So what you can see, it is a return type is a node. Now you will ask me this question that Arnav, There is no return type known as node. Then how can a particular function is giving a return type as node? Yes, it can, because here this function is returning the object of the node class. That's why we have already made the node class in top, or this function is already made by GFJ in top. And then we have to sort this doubly linked list. We have to pass the node head in the parameter of this particular function as a head, because we have already studied in this about linked list that first we have to make a fast pointer, and initially both pointers point to the head of the linked list, right? So similarly, we have to be very clear about this, and we have to make a driver code. So the driver code is a very big code which is already made by GFG. So if you see the driver code carefully, it is taking an int data in the node class, and then it is also taking an int key, and then there's a driver class which is taking the number of t is equals to sc.next. This is the number of test cases when n equals to sc.next. N is basically the size of the array, and a1 is also there. So now you can see individual elements of the array are being added and nodes are being filled. So if you see in the driver class carefully, the nodes are being filled. And lastly, head equals to new solution. Solution is the name of the class which is calling the function sort doubly and passing the value head into it. And then finally, you can see in the output that two lists are being printed. So how you're going to print list? For print list, we have separate function known as void print list. So the void print list basically prints the data stored in the particular node. So you can see node.data has been kept in the print statement, and initially the temp is dot and temp dot equals to node. So it is basically updating it with the present value, with the next value, and so on, and it is going to print it, right? So if you don't know a print function of the print list, I would suggest you to solve some problems on printing list and printing a linked list and all those things, and it will be a bit easier for you, right? So let's solve this problem. First, the problem what I have approached is using a merge sort. So if you see in case of a merge sort, what we have to do is basically first we are taking an import of a scanner class to take the inputs. Then we have created the class node, which I've already created. I have already told you a node class has been created, and this is the constructor. So I can write like this, constructor, right? In order to understand, then we are initializing the values passed in this particular constructor. Next, what we can do is we have to create a class merge sort in doubly linked list 1. So say this is the name of my class. So the name of the class can be class solution based on the question given. Now I have taken static node merge. So this is basically doing the merge operation, right? In the static nodes merge, I have to check some constraints that if one of the list is empty, return the other list. Yes, it is very true. So how we are going to understand a list, right? So first you can see there is a node left and a node right. So whenever you are given a list, say a complete list is like 1 to 8, and we are breaking the list into left and right, because whenever we break the list, a list is broken into two parts or two sub-arrays, as we have already studied. Now, if one of the sub-array is empty, so what we can do? So say for example we have 8 elements in a linked list, and the first 5 elements are just 0. So you just can't print like 0, 0, 0 and 1, 2, 3, 4. No, you have to omit the zeros and you have to return the right. So if you see the left position is null, means if there is no elements present in the left direction of a linked list, obviously what we have to do is we have to print the right. Similarly, in the case of a right, so if you see there is no coaches on the train on the right side of a train, so what, the train will not move or what? Yes, the train can move, but with the existing coaches which are on the left side. Similarly, you have to understand what we have to do is we have to again check some constraints. Some of the constraints are the smaller node as the head of the merge list. Yeah, choose the smaller node as the head of the merge list. So if you see left dot data equals to right, then we have to call the merge function, and then eventually we are going to sort it. So in this particular if statements and the else statements, it is basically telling, okay, so if my left element is smaller than the right element, so what I'm going to do is I'm going to merge the left and the right. And merge the left and the right is done using the merge sort function, which is coming below. Okay, so you have to see another thing, you have to see and observe another thing very carefully. All of these functions I have created, a static node merge, a static nodes merge sort, and a static node sort doubly. All these functions have a return type, something in common. You have to understand like this, something there is in common, right? So if something in common in between these functions is a node, so basically a node is nothing but a return type in this case, and the return type is defined because I've already created a node class. So once we have checked the left and the right, now let's understand the core concept of merge sort function to perform merge sort on a doubly linked list. So in the case of a core concept of a merge sort, what basically we are doing is first we are taking that if head is equals to null, or head dot next equals to null, return head. Yes. So what I've basically seen is, suppose I'm standing over here, and in front there is no elements. In that case, I will return where I am, right? I cannot go back, I cannot go in the front, but I have to return where I am. And similarly, in front, head.next is also saying that is null, then we have to return null. So these are nothing but the base cases. Now we have already discussed that in case of our doubly linked list, we are going to use the concept of slow and fast pointers. So both initially, if you very clearly understand the Word document, so this Word document, I've made the Word document for your understanding. In the algorithm, what it is written, we will maintain a fast and slow pointer, and initially both pointer will point to the head of the linked list. So if you want to check whether I am telling it correct or not, you can see I have made slow and fast pointers and I have initialized them as head. So slow equals to head and fast equals to what dot next. Then I'm going to run a while loop. As you know, in case of linked list, we have to always check this condition whether our particular position is null, or if it is null, so we will move. If it is not null, we will move in the forward direction, and until it becomes null, we are going to keep on moving. Next, we are going to split the list into two halves. So you can see node second half equals to slow dot next, second half equals dot prev equals to null, and slow dot next equals to null. So if you see very clearly, the first half is what, the first one, right? The next. So if you see something is fast dot next, now you will see, Arnav, you have already told in this particular algorithm that now we will move the slow pointer by one node at a time and fast pointer by two node at a time. Yes. So don't get confused with my code. I've made it in a very understanding and easy manner. So whenever you are saying one node, you have to read the corresponding question. In case of a one node, it is one time next. So we will write dot next for once. We are not going to write dot next, dot next, dot next. So whenever in case of fast, it is saying clearly that in case of a fast, the fast pointer is two nodes at a time. Two nodes at a time. So in case of a fast, we can analyze this algorithm as next. You can see very clearly what it is written over here as next. Means next is two times, two nodes at a time it is going to move, because something has to go faster, right? One thing is going slower. No, other thing has to reach in the end and then give signal to the fast one, right? And just imagine in case of a real life example, and you will understand why there is why you have to first see what I have already. If you don't understand, just skip behind in the video and try to understand what I have already explained about the linked list. Next, what it is saying, we have to split the linked list into two halves. Yes, and then recursively sort both the halves. So if the second half is slow, and then you can see what this is doing is slow.prev equals to null and slow.next equals to null. So basically what we are doing is we are splitting the list into two halves and merge sort head, merge sort second half. So what is our first half? If you try to remember what is our first sort. So the first merge sort is a function which is recursively called. So if you see very clearly, this is the power of IntelliJ. I would always suggest you guys to use IntelliJ for doing problems in Java. So if I select this particular function name, I can see in my code where this function is being called again and again. So this function is called inside this function. So that means recursive algorithm has been used to sort it. Now finally, we are returning the sorted halves, which is left and right. Now static node sort doubly is return merge sort head. So this is just one line. So you will just laugh if I tell you that in this particular GFG template, I have to just add one line. No, our core function lies above. Our core function lies above. It is present over here. If you see it very clearly, it is present over here. Okay, so let's come to the print list. The print list function is already there to print the list, and then I have made a static void main method, which is basically taking the number of elements as n, and then I've initialized the node head and the previous node as null, and I have taken the input of every particular element in this particular line. Then I've initialized node new node equals to new node and value, and after that I have sorted the doubly linked list by passing head as parameter. This head is being passed in the parameter and it is printed. Say for example, if I want to check the particular problem. Yeah, so if I want to check the particular problem with my question statement, so if you see the number of elements is 8, right? And we have to add the elements individually, right? So the elements can be 7, 3, 5, 2, 6, 4, 1, 8. So if I see whether I have done it correctly or not, yes, I have done correctly. See, the output is coming 1, 2, 3, 4, 5, 6, 7, 8, and the reverse list is and the original doubly linked list is 7, 3, 5, and the output is coming 1, 2, 3, 4, 5, 6, 7, 8, right? So what we can see clearly that we are successful in sorting the array. Right? Similarly, now what I'm going to try is I'm going to implement this code on the GFG platform and check whether this particular code is working or not. So what I'm going to do is over here, you can see there is a class solution. So this is a class solution. I'm going to delete this solution. I have to just take this code from here, which I've explained. I have to take this code. And then what I will try doing is I will take this as class solution. and I will name the C as here and try to compile it. So you can see it is giving a correct output, right? So which is basically the time complexity of O log n. So I have discussed over here as well that after solving the merge sort on doubly linked list, the code is given over here as well. So if you want to just see what the code is, you can just pause the video and carefully see the code from here as well. I will try to upload the explanation of this merge sort in a Google Drive and share the link on the description as well. So you can see the time complexity is O log n. The worst case for the merge sort is O log n. So yeah, so if you see the time taken is 4.38 seconds and I've already solved this problem. Now what I'm going to do next is something interesting. What I'm going to do next is I am just going to try the easier part. I'm going to try the easier part. So what is the easier part? So the easier part is, first let me bring back this particular problem statement to its original state. So this is the problem statement to its original state, right? Yeah. So next what I'm going to do is I'm going to solve this problem using an easy trick, right? Using an easy trick. So how I'm going to solve this problem? Easy trick, I will write over here. So if I write over here easy trick, what I can see clearly is I have to take an array list, say array list of integer, because this particular platform doesn't know how we are solving it. So we can take it as new array list. Yeah. So once array list has been taken, what we are going to do is we are going to take current node, say curve1 equals to head. Okay. Now we are going to curve1 dot next not equals to null, because our loop will only work until and unless this thing becomes null. Here dot add, what I can do is I can add the particular elements, current one dot data. So if you see in the current one data, I'm taking the current, then in current one equals to 1 dot next. So when the while loop is being created, I have to add the elements curve dot data. Now after adding the elements, I have to traverse through I will sort it, so I can use this is the inbuilt method to solve a linked list. So if you see, here is the cheating part, here is the part which I have used a short trick. So in case of entirely developing the concept of a merge sort where you have to divide, conquer multiple times, you have to break it, what I can basically do is I'm just using collections.sort in order to sort this particular array. So you can write current one dot data and it will sort it. Yeah. So next what we are going to do is node cur. So this is not cur1, this is cur, remember, equals to head, current equals to head. I've initialized it. Now I'm going to traverse through it less than this arr dot size. So if you don't know, you cannot write arr dot length over here because this is a linked list. And in case of an array list, the way to define the size is arr dot size. So similarly, what I'm going to do next is cur dot data equals to arr dot get of I. So basically it is taking the data which is being stored in this array in sorted order. Current equals to cur dot next. So when the for loop is being completed, what we can do is return the head. And this was the previous thing, so we don't need it. So this, I guess we have so if you see, this is class solution and this is doubly linked list. So let's try and execute. Collections.sort, no suitable method for sort of int. No suitable method found for the sort int. Collections.sort. T1 as not applicable. Let me check. Collections.sort. Sorry, I have to put arr over here. So if you see, that entire problem of so many lines over here just can be done so easily. This was such a big problem, but it can be done so easily using the inbuilt method of collections.sort and using the concept of array list, because the GFG driver code is not checking technically whether you have used a merge sort or not actually. So you can try to use the short trick, but I would always recommend you to learn how merge sort works, because in some questions there will be some time complexities where you have to accurate merge sort will be greater than the others. So we will find out what is the time complexity of this particular problem. The previous one was 4.3 seconds. So I have to check whether this is more than that. This is more than that, definitely more than that. So if you see 4.4 second was the previous one, and this is 4.64 second, and if you see it has an accuracy of 100% accuracy, right? So now what you can check is the submissions. If I go to the submissions, in my submissions, if you see the first problem statement has a submission of 4 points, and these are all the correct ones. Yeah. So this was all about merge sort on W linked list. I hope you enjoyed learning this new concept on W linked list. Thank you. See you later.